Hello everyone. I'm Jennifer Bronze from the Light and Health Research Center at Mount Sinai. I've been working in lighting for 25 years, so I'm going to share some information about how I do field verification of design results. As we saw in previous videos, following the UL guide requires a lot of steps. What I'm talking about today is not one of the design stages, but rather a follow-up after construction and move-in. While the UL guide shows this validation as optional, the P100 shows that measurement and verification is required for Tier 2. There are several preparations I make before I do my field verifications. The first thing I do is discuss with my site contact what the hours of access will be. Is it best for me to work overnight when the building's vacant, or on the weekend, or alongside the real occupants during a normal workday? Your site may have security inspections or may limit devices that you can bring into the building. For example, when we work with the GSA to evaluate high security buildings, our equipment has to be pre-approved for entry and/or wireless equipment must be disabled. If you're trying to measure lighting that changes with the time of day, you'll need to make sure that you have access to override time-based controls or daylighting controls. Many buildings require that I notify them in advance which of my colleagues I'm bringing for the site evaluation. I'll ask about the photography policy in advance. And lastly, I typically notify my contact which activities I will actually be doing so that the occupants are not alarmed. That may mean that I'm going to be switching off lights or dimming lights or closing blinds and shades, for instance. At your site evaluation, you should expect to be making a lot of notes showing light levels at particular desks, which you may have to keep repeating. I like working with a paper copy of the lighting and furniture plans, a large clipboard, and multicolored ballpoint pens. But other colleagues like to work with a tablet or with a laptop and a worksheet. In any case, I work with a worksheet to help me to make sure that I'm being thorough with the repeated measurements at various times of the day or various lighting conditions. I typically use the desk numbers that are in use at the site, or sometimes I have to create my own numbering system. Sometimes I'm able to do all this in advance, and other times I have to actually make the decisions once I reach the site. I try to choose a few desks that are typical, far away from daylight or other lighting that isn't what I'm trying to measure. In terms of meters, you will certainly need to bring a calibrated illuminance meter. Also bring a spectroradiometer to verify the color characteristics of the lighting. You'll need a way to hold these meters in place in the right location, so bring a tripod and a tape measure. If you're taking notes by hand, bring a clipboard and pens, as I mentioned. And you'll need to repeatedly measure the same desks, so I like to use adhesive dots or post-it notes or painter's tape to standardize alignment of my measurement equipment. Some optional packing items might be some fuel to keep you working efficiently over long hours, such as snacks and beverages. And you'll probably want to take photos of each of the measurement conditions. If you're measuring when the space is occupied, you may want to bring printouts of a photo release consent form. After you've made all your arrangements, it's time to make the measurements on site. The first thing I do when arriving at the site is to prepare it for the measurements. Now, since you're trying to measure the impact of electric lighting, you need to limit your daylight. Unless you're working overnight, you need to block your windows, lower blinds, close curtains, and I did have a project once where I had to go up on the roof to cover up skylights for my measurements. If there's still a little daylight coming into your measurement space, you'll need to make 2 measurements at each time, one with daylight and electric, and then switch off the electric light to get daylight only. Then later you can subtract the daylight only measurement to calculate electric only contribution. If you're not overriding the time-based control system, you'll have to repeat the measurements at various times of the day. And if you're working on a weekend or overnight, make sure you can override the lighting controls, such as a time clock sweep off or daylighting controls. The UL guide recommends that you perform measurements at 10 representative desks at a minimum. Don't choose unusual desks, but rather ones that are most typical, and try to stay away from daylight, as I mentioned before. If you have a choice, include desks that you also included on your calculations. At each measurement desk, add an adhesive registration mark and a note to remind yourself what desk number you're at. You're going to be measuring illuminance at the eye, as I'm showing here. The UL publication shows that you should be measuring at a height of 43 inches or 1.1 meters. The P100 says you should also measure at a standing height. Now, in your notes, indicate what light meter model and units your light meter has, such as foot candles or lux. And when you measure each desk, you should use your spectroradiometer as well at those same eye positions. In addition, I like to get up on a ladder and measure spectral characteristics for each color output of my light fixtures, right at the source of the light. While these documents don't require it, I usually measure horizontal illuminance at each desk, since I do find that to be a useful comparison to other industry standards. You should use the same procedure at all 10 plus desks. I like to document with photos if that's allowed. If your electric lighting is designed to dim up and down at several times of the day, you will need to revisit those 10 or so desks repeatedly in the morning, afternoon, evening, etc. If you're taking photos on site showing each of those lighting conditions, I want to remind you to avoid sensitive materials. These might include phone lists, financial information, medical information, name tags, personal photos, and especially photos with children or other protected individuals. I try to work with vacant desks for that reason to minimize those concerns. There may be an approval process for any photos you take on site. Now I have some reminders for you after you've collected all your data. The last thing I do on site is clean up. I remove those adhesive registration marks from each of the 10 or more desks. And I try to return the window coverings back to the state I found them in and make sure the window lighting controls are back in their normal program mode. Now when you're back at your desk, you will need to organize all your data. If you did handwritten notes, you might want to scan your notes. You will collate all your information by desk location and lighting condition and create some graphs summarizing the results. You'll use your spectral data and your vertical illuminance data to run your CS calculations at each of the 10 or so desks. And here's a link showing the most updated CS calculator, which you learned about in video 6. Lastly, you'll compile a report summarizing your field validation and comparing it to your predicted values. Lastly, I'm going to touch on 2 ways to measure the impact of new lighting on the occupant's circadian system, their sleep-wake cycles. The UL publication recommends working with occupants to measure the impact of sleep before and after new lighting. There are wearable actigraphy devices that measure patterns of activity and rest. Activity is based on technology developed over several decades and has been repeatedly validated against lab-grade devices. In order to measure the impact of lighting on sleep, participants would need to wear a device before they move into their new office and then again after they move into their office. Note that this will involve personal information, so if you're going to be publishing the results, you'll need permission from an institutional review board to work with human subjects, as it's called. If you do collect actigraphy data, you'll perform these kinds of statistical analyses I'm showing here on the left to compare whether their sleep cycle is, and sleep-awake cycle is disrupted, like I'm showing here in the middle, or is it more consistent or cohesive, as I'm showing on the right. You'll administer these devices not the first day people are moving into their new building, but rather after several weeks of exposure. It takes time to adjust for the lighting to have a good effect on people. Make sure that you're administering at the same time of year, not comparing, say, winter to summer. Lastly, you could perform sleep quality surveys. If you use a standard one, such as the Pittsburgh Sleep Quality Index Survey or the PSQI survey, you could compare your occupants to others in the literature. Again, you need to measure before and after people work in the new lighting. And this type of measurement is interesting because it's subjective, in which the participants state their opinion about the sleep quality. But these types of questionnaires are helpful because they're less challenging for participants to adhere to compared to wearing these kind of measurement devices I said in the last slide. Well, that's a summary of field validation, the final stage in the process. Thank you for watching this series.